This is our last lecture of chapter 3. This is our lecture 7 and we learn code in details. So here, what is code? Actually, the code is a specific number for any kinds of letter, number, symbol, or any kinds of object. That means code actually define the identity of an object. Okay, I repeat, code actually define the identity any kinds of object. So that means if I elaborate or explain, like your school has a dress code, right? That means you have a fixed dress. You have a roll number, that is a fixed number, right? You have an NID number, if you have, that is also a fixed number, right? So this number actually represent your identity. That means this number actually unique for your school or for your nationality, right? So I have to change my pen color. Now the code is the specific binary number found for various letter, number, symbol is called the code. Actually, how code works and why we need this code. If I give an example to you, when this is a computer, when we give input A as a letter to our computer from our keyboard, this is input, and the computer need to understand what I actually input, right? So then they don't understand our language. ABCD is our language, right? This is the alphabet. So when we write this A, then the CPU means central processing unit, this part need to process this A. So this is a processing. We already know that the computer has 3 steps. So one is input, another one is processing, and final one is output. So when we input an A to our computer, then this CPU needs to convert to their language. Okay, so then they converted this A to their language, and for like binary, they have binary for this A, and they understand what I actually write, and after that they give an output for me. This is A. So that means there is 3 kinds of process. One of them is input, another one is processing, and final one is output. So how they actually understand what I actually write? I write a capital A. If the computer give me output is a smaller a, we don't like this, right? So if I input capital A, I have to see the capital A as our output. So for these kinds of procedure, we need a unique number for every character, right? So that means we have a 26 character for capital A, capital Z. We have a 26 character, right? So this character has a unique roll number. For A, this is 65 to 90. That means A means 65. For capital A, this means 65. For capital B, this means 66. So the capital Z means 90. We have 16 rows for them. So also we have for smaller a to smaller z, we have also some different roll number. This is 97 to 122. So that means if we write A, then the computer will they have a unique number. This is 97. So this is 97. This smaller b means 98. So the z means 122. So in this way, computer actually understand our different letter. Okay, our capital letter or small letter, we have a different number. So how can I understand that this is starting from 65 and how computer actually convert this 65? This 65 to 90 is actually in decimal number system. We write here in decimal number system for our better memorization. So here if I write A, that means computer, this is the roll number 65, so computer need to convert this. So if you convert this 65 from decimal to binary, you will get the actual binary number for this A. So we already know that how to convert a decimal number for to a binary number system, right? We already know that. So 65, if I divide it by 2, so you will get 32. The remaining value is 1. We also need to convert divided by 2, so you will get 16. You will have 0, so on, so on. I already know that the binary of this A, so I write here directly. So you will get 1 0 0 0 0 0, 5 of 0 and 1. So you will get the 7 digit of binary for this A. So computer will understand this binary for this A, for this capital A. So here, if I ask you what is the binary for smaller A, so you have to convert this 97 to binary number, then you will get the actual binary for this smaller A, right? So also you can find a question in your paper that what is the binary for capital G. So if A is 65, B is 66, so you will get the value for G. Then you have to convert this decimal number to binary number system, then you will get the actual binary for this G. So for this reason, we need a specific identity for any kinds of letter, number or symbol to understand the computer. Okay, so why actually code need, do you understand? Not only for this character, also computer need a unique identity for any kinds of digit like 0 to 9, or any kinds of symbol plus, minus, or a special character like exclamatory sign or hash. For this symbol or letter or digit, computer also needs those kinds of binary. This is called code. So here the most popular code is alphanumeric. From the beginning of the civilization, we found a lot of code, but nowadays we are actually using this alphanumeric code. If I explain this, alpha, which represent alphabet, and numeric, which represent number, so which coding system can give the identity for any kinds of alphabet and numeric number is called the alphanumeric code. Okay, I repeat, which number system can give the code for any kinds of alphabet and numeric number, that is called the alphanumeric code. So here is the another explanation, another definition. The code used to represent letter A to Z, digits 0 to 9 and various mathematical symbols plus, minus, etc., as well as a special symbol like exclamatory hash at the rate, that is alphanumeric code. Alphanumeric code is called. So this is the actual definition for alphanumeric code. So we have a lot of example for alphanumeric code or lot of classification, but we have just 3 kinds of alphanumeric code in our textbook, so we have to write those 3 coding system. So this is one of them is ASCII code or ASCII code, another one EBCDIC and Unicode. All of them is in alphanumeric code. Okay, so here we learn ASCII code. So ASCII, the explanation, the elaboration for this ASCII is American Standard Code for Information Interchange. So you have to learn this spelling and pronunciation properly, because you can find the question like what is the full form of ASCII. Huh? So you have to learn the full form properly, and you can also have the question in your MCQ that what is the correct spelling of ASCII. Okay, so you have to learn this properly. So here this full form is American Standard Code. So this is the American Standard Code for information interchange. So all we know that at first computer is invented in US or America, right? So so they want that computer will understand their language at first, right? So that's why they need to give the unique identity for each of the letter or each of the digit or symbol using in their language, right? So that's why they invented a system, that is ASCII, which can interchange their information. That means ABCD is their information. They can interchange their information to binary number system. This is American Standard Code. Do you understand this part?
Yes, sir.
Okay. So what is the use case actually? The usage is English alphabet A to Z, capital and smaller, and number and sign. For those things, the ASCII code is generated binary for those alphabet, number and sign. So here the length of the binary, or the length of the unique identity is 8-bit. That means for A we get 7-bit of binary, right? But they add 0 before this one and they converted it into 8-bit. So at first actually ASCII was in 7-bit. Beginning of this ASCII system, ASCII was in 7-bit, but after that they add 1 bit extra, then it converted to 8-bit. Now we are using ASCII 8 and ASCII 7 are used in previous time. So here ASCII code we are using here ASCII 8. At first the ASCII 7 was invented, after that ASCII 8 was regenerated coding system. So here this is the 8-bit of binary, the length of this ASCII code, and the range. What is the range? Range means ASCII number system, sorry, ASCII coding system, how many alphabet and how many number or how many sign they can give their identity. ASCII can give their identity to 256 unique number, digit and letter and sign. So ASCII can give the unique identity for 256 unique alphabet, number and sign. Okay, so how can we find this this number 256? Actually we are going to find a code for binary number, right? So we generate this code by this binary number system. That means we have 2 binary digit and the length is 8 bits, so the power is 8, then you will get the 256. Okay, so we found that ASCII can give the identity for 256 unique alphabet, number and sign. So this is the actual system. So the range is 256 or 2 to the power 8. You will get this question in your MCQ. So also you can find this question, that what is ASCII, explain it. Then you have to explain the use case, the length and the range for this ASCII number system. And you can also ask for different question like Adrika invented a coding system. Which coding system used 3012, 3 digit of number, and the length is 9-bit. Okay, Adrika invented a coding system. Which coding system has 3-bit and the length is 9-bit. 0 and 2 is their basic bit and 9-bit their length. So how many letter or how many unique number they can have? They have how many number, right? So you can find, like, you have 3 digit and the length is 9-bit, that means 3 to the power 9. You can calculate this by your calculator, you will get a number. So those like 3 to the power 9, what is the answer? I have to find 3 to the power 9. So sorry, three to the power 9. So can you calculate this? I don't get my calculator. You will get a large number, right, for 3 to the power 9. So this is the actual result. So ASCII actually used for English alphabet A to Z and their number and sign. And I repeat that in this ASCII coding system, the capital and smaller character has actual value is 65 to 90 and 97 to 122. This is very important for this ASCII number system. Okay, so in this in this coding system, A to Z we have 65 to 90, and smaller A to Z we have 97 to 122. Now the topic is EBCD. So the full,
ask a question?
Yes please.
Is ASCII and ASCII are the same thing?
Yes, ASCII and ASCII is the same thing.
No, not ASCII. Like the ASCII and ASCII are that we use for coding sometimes.
Please, you can repeat.
The ASCII and ASCII art. You know the art that is done by ASCII? Like I did it in my coding a few days ago, so I'm asking if they are the same thing.
Yes, actually this is the same thing, because ASCII actually represent the unique identity. The unique identity for any kinds of English alphabet, number and sign. Okay.
Okay, sir.
Okay, then EBCDIC. The full form of EBCDIC is Extended Binary Coded Decimal Interchange Code. So this is a very important full form, and I have to mark this part, binary coded decimal. Okay, just remind this is BCD means binary coded decimal, and EBCD means Extended Binary Coded Decimal Interchange Code. So here we also, this code EBCD code usage is English alphabet also, as same as ASCII. Okay, so English alphabet A to Z, number and sign, they also have 8 bit, and the range also 2 to the power 8, that means 256. But here we are using 65 to 90 for capital A to capital Z. But in this coding system, for capital A to capital Z, we don't use 65 to 90. Okay, on this period actually there is a company called IBM. This company invented a new coding system. This is EBCD, where A does not contain 65, where ASCII code define A as 65, but in EBCD they don't use this 65, they use in different value. Okay, so here we have a different value for A, and we also get the different binary for this A. But nowadays we don't use this EBCD code, we have to just read. Okay, ASCII and EBCD has the same concept. They want that English alphabet, number and sign, for those things they need the binary or they need the code, but they don't use the same code for each of the number or each of the alphabet. Okay, they had different binary or different code for those. Okay, that's why EBCD is a different, but we don't use this coding system nowadays. So this is our EBCD code. EBCD code also have 8 bit, and EBCD code, the range of this is 256. All of them are same, but they are not same as their number. Okay, so now we have a final part. This is Unicode. So Universal Character Encoding Standard. You don't get the full form in your book, I hope so. So you have to write or you have to note this properly. So Unicode used for any kinds of language, any kinds of language. Nowadays we are using our alphabet in our computer, right? So computer also need to understand those digits and those letters. Also in Arabic we are using this, right? So computer also need to understand those alphabet, those character, but where ASCII and EBCDIC is not responsible for giving the code for them, right? Then Unicode comes and give their different code. So Unicode actually used for any kinds of alphabet in any language, any number and any sign. So the length is 16-bit. They also need the more bit because they had a lot of language, so lot of alphabet, lot of number, lot of sign. That's why they need more bit. So the length is 16-bit and the range is 2 to the power 16 because we are using 0 and 1 here. That means 2 bit of binary and the range is 16-bit. So 2 to the power 16 you will get 65,536 different number, and those number is used for different alphabet, number and sign. Okay, so you can ask me a question there. So A in English A to Z is used for ASCII, right? This ASCII number system give the code for A to Z. Then is Unicode give the code for this capital A to Z or smaller A to Z? Yes, the answer is yes. Unicode also give the code for English A to Z. Okay, so actually a computer, when we write this alphabet in our computer, what actually used by this computer is computer use ASCII code or Unicode. Actually ASCII code give their space from 0 to 256, 0 to 256, and first 256 cell are free for this ASCII number system. After that they used different code for different language. Okay, so here is our Unicode. So you can ask a question like in Hindi, what kinds of code used for computer? So Unicode is your answer, right? In any language you can get the code from Unicode. Okay, so if you have any question you can ask me. Maybe not. Now we have to move our next part. This is our different part. This is BCD. BCD means binary coded decimal. This coding, this BCD code is not exist in ASCII code. This is a different coding system. Okay, BCD and alphanumeric is different type of coding system. Okay, alphanumeric has only 3 category: ASCII, BCD and Unicode, and BCD is a different category. So BCD mean binary coded decimal, what actually we found in EBCD. Okay, this BCD coded, I repeat, this is coded, not code. Okay, you have to remind this. So binary coded decimal, here BCD means binary coded decimal. We also have this part coded decimal. That means BCD code only responsible for giving the code for any kinds of decimal number. So use case is decimal digit 0 to 9. Unicode BCD code can give the code for decimal digit 0 to 9 and each digit length 4 bit. That means we can find 4 bit for each of the decimal number. So at first I have to give an example to you, like 797. Okay, for this is a decimal number. We have to find the BCD for this decimal. So we have to find 4 bit of binary for each of the decimal digit. So we already know the chart 1248. You can find the binary from this chart. This chart we are already used in hexadecimal to binary number system. So this is the chart you can use here also. So 9, we need this 9. So we need the column of 8 and we need the column of 1. If we add those column 8 plus 1, you will get 9. We don't need those column 4 and 2. That means we put here 0. So the result is 1001. Also we need the binary for 7. So 4 to 6, 6 plus 1 is 7. So we don't need this column. So the result is 0111. So ultimately the result is 1001 and 0111. So what is the base for this binary? Can you tell me? You have a gift if you can.
Is it 2?
Okay, you think that this is 2, and you must must do this mistake in your exam. I know that, that's why I ask all of you. The base is BCD. This is not the binary number system, okay? Because we know that if I want to convert a decimal number to a binary number system, we have to divide the integer part by 2. So that means if we need this the binary for this 97, you have to divide 97 by 2 again and again unless you get the 0. So here we find the 4-bit for each of the decimal number system. That means the base should be BCD, okay? So the binary and BCD is not the same things. So for this concept we need to clear. So here binary versus BCD, we have to find a comparison. So here is 57 is our decimal number. We have to find the binary for this decimal. Now we know that for decimal to binary we have to divide it by 2 for this integer part, because 2 is our base for binary. That means we will get 28 for the result is 28 and the remainder is 1. Also you need to convert divided this by 2, then you will get 14 and the remainder is 0. Also we divided this by 2, so 7 is our result and 0 is our remainder. Also divided by 2, 3 is our answer and 1 is our remainder. Also, so you will get 1 here and 1 is our remainder, and divided by 2 you will get 0 and this one is our remainder. So the result is 57. For this 57 you will get 111,001. So 1 1 1 0 0 1. We know that we have to pick the number from bottom to top. So this is our MSB, this is our LSB, most significant bit and least significant bit. Where if we find the BCD for same decimal number, what you will get? So you need BCD. So here 57. So if you done this conversion, you will get 0101, 4-bit for this 5, and for this 7 you will get 0111. So ultimately the result is 57 and 0101 and 0111. So is those number are same? Absolutely not. This is 111001 and this is 101011. So that means those two binary is not same. Sorry, we have to write here BCD. This is our BCD code and this is our binary. We convert the same number to binary and BCD and we get the different value. Okay, so what is the difference between binary and BCD? This is you will get this question for 2 marks. So you have to find the difference. You have to write the difference properly. So you write just what you see actually. For having the binary, at first we explain the rules for having the binary, or for find the binary number for this for any kinds of decimal number. We have to divide it by 2 for integer part, and this is we'll get our binary result. And for BCD we have to find 4-bit of binary for each of the decimal number. Okay, this is number 1. And number 2 is the base of the binary is 2 and the base of the BCD is BCD. And number 3 is for this the binary number should be smaller and the BCD number should be longer or larger than binary. That means here you get 6-bit of binary and here you get 8-bit of binary. If you avoid this 0, you also have the 7-bit of binary. That means the BCD number should be larger than binary. Okay, and number 4 is you can find the binary for any kinds of number system or for any kinds of octal or hexa, but you can find the BCD for only for decimal number system. Now I have a question and I have to ask this question very seriously. Sorry. here if you have 7 4, so what is the BCD for this number? How can we get the BCD from this number? Zara?
So do you have to convert the octal number to decimal and then do the BCD for it?
Very good, exactly. At first sight, you can convert this octal to BCD directly. If you done this, this is absolutely wrong. You can't do this directly. Okay, at first you have to convert 74 octal to decimal number system. We already know that rules. How can we convert this? Then after that you can convert from this decimal number to BCD code. Okay, so this is the actual process. That means from octal to decimal and decimal to BCD. Okay, this is the actual procedure. If you have also hexadecimal number, you have, so you can convert this in decimal number system. After that you can convert this BCD. Okay, this is the actual procedure. So actually you have to remind those rules properly, otherwise you must do this mistake. So if you have any question, you can ask me. সো তোমাদের কারো কোনো প্রশ্ন নাই? আদ্রিকা সবকিছু বুঝতে পেরেছো? আরায়ানা, আদ্রিকা, যারা?
Yes, sir.
এই ক্লাসটা খুবই ইম্পর্টেন্ট ক্লাস। এটা একটা ফিনিশিং ক্লাস তোমাদের এই 3.1 এর। আজকের ক্লাসের মধ্যে দিয়ে আমাদের এই চ্যাপ্টারটা শেষ হয়ে গেছে এবং আমরা খুব ইন ডিটেলস এই চ্যাপ্টারে যত ধরনের প্রশ্ন আসতে পারে সেগুলো নিয়ে কিন্তু আমি ধরে ধরে কথা বলছি। কোথায় কোথায় কি কি প্রশ্ন হবে, যেমন এই এক্সট্রাঅর্ডিনারি প্রশ্ন যেভাবে হয় সেগুলো বলছি এখানে। আবার তোমার এখান থেকে ডিফারেন্টটা বলছি যে এখানে এগুলো ধরাই দিছি যে বিসিডি কোডেড কিভাবে লেখা থাকে। তারপরে এখানেও আমি বুঝাই দিছি যে ইউনিকোডে অ্যাকচুয়ালি সকল ভাষা আসবে, এভাবে প্রশ্ন হতে পারে। অলসো এখানে বিসিডি কোডটা কোথায় ব্যবহার হয়, এটা অনলি ডেসিমাল নাম্বারের জন্য ব্যবহার হয় সেটাও বলে দিছি। হ্যাঁ, তারপরে হচ্ছে এই ডিফারেন্টটা বলে দিলাম, পাশাপাশি কিভাবে অন্য পদ্ধতি থাকলে বিসিডি দিয়ে নিতে হবে সেটাও বলে দিছি। এর বাইরে এখানে আর কোনো ধরনের কোনো প্রশ্ন হওয়াই সম্ভব না। হ্যাঁ, সকল পসিবল কোশ্চেন আমার এক্সপ্লেইন করা শেষ। এখন আসি তোমাদের কাজ কি। তোমাদের কাজ হবে এই চ্যাপ্টারটাকে একদম স্টার্টিং থেকে এন্ডিং পর্যন্ত খুব ভালো করে একবার রিভাইজ করা। রিভাইজ করার পরের কাজ বইয়ের পিছনে যে এমসিকিউ পার্ট আছে সেগুলো সলভ করা, যে সিকিউ পার্ট আছে এগুলো সলভ করা। সলভ করার পরে এখান থেকে অবশ্যই কিছু প্রশ্ন আসবে, সেই কোশ্চেনগুলোকে কালেক্ট করা, যেগুলো তোমার বুঝতে অসুবিধা হয় এমন কোশ্চেনগুলোকে কালেক্ট করা। সো যখন কালেক্ট করবা সেগুলোকে আমাকে নেক্সট ক্লাসে দেখাবা। এবং রিমাইন্ডার হচ্ছে তোমাদের আগামী ক্লাস হচ্ছে একটা এক্সট্রা ক্লাস থাকবে আগামী শনিবার, ঠিক আছে? আগামী শনিবার দিন আমরা চ্যাপ্টার 1 এর লেকচার 3 পড়বো। লেকচার 1 আর 2 হয়েছে আমাদের। অ্যান্ড তোমরা তো শনি সোম বুধের, হ্যাঁ ঠিক আছে, আগামী মানডে হচ্ছে তোমাদের এক্সাম থাকবে, এই চ্যাপ্টার 3 এর উপরে এক্সাম থাকবে। সো শনিবারের মধ্যে তোমরা এই চ্যাপ্টার প্রবলেমগুলো নিয়ে আমার সাথে বসবা, অ্যান্ড চ্যাপ্টার 1টাও আমরা ইনশাআল্লাহ শনিবার দিন শেষ করার চেষ্টা করব। তাহলে মোটামুটি কাজ শেষ। আরেকটা বিষয় হচ্ছে তোমরা তো এখন ফ্রি আছো, আমি চাচ্ছিলাম ক্লাসটা একটা দিন বাড়াতে, মানে আগে তো সোম বুধ নিতাম, এখন শনি সোম বুধ করতে। তোমাদের কি কারো কোনো প্রবলেম আছে এটা করলে?
No, sir. Okay.
আচ্ছা,
Sir, I think I have a problem.
বলো কি প্রবলেম হবে?
I have computing classes at 9:30 on Saturdays. Can we take the class time to sometime else? Like 6 p.m. or something?
তোমার শুরু হবে কয়টা, 8টা থেকে নাকি 9:30 থেকে?
No, sir. 9:30 থেকে।
9:30, তাহলে আমরা 8টায় নিতে পারি। বাকিরা কি বলো, 8টায় করা যায়? আদ্রিকা?
Yes, sir.
আচ্ছা, আর না প্রবলেম না। আদ্রিকা তুমি একটু বলো তো স্যার, 8টায় করা যাবে?
Yes, sir.
আচ্ছা, তাহলে আমরা আগামী স্যাটারডেতে 8টার দিকে আমি ক্লাসটা নিচ্ছি। এবং আরেকটা বিষয় কি যেন বললাম, তোমাদের সোমবার দিন এক্সামটা হবে। আচ্ছা, আর প্রশ্ন, আমাকে একটা প্রশ্ন করছিল এসকে কোড নিয়ে, এটা মনে হয় যারা করছিল। তোমার কি এই ব্যাপারটা ক্লিয়ার হয়েছে যারা?
Yes, sir.
আচ্ছা ঠিক আছে। সো তোমাদের এই লেকচারগুলো আগামীকাল আপলোড হবে, আর প্রিভিয়াস সকল লেকচার কিন্তু আপলোড হয়ে গেছে। সো এটা চেক করবা তোমাদের সার্ভার থেকে, যার যার সার্ভার থেকে চেক করবা। ওকে, থ্যাংক ইউ স্যার, আজকের জন্য এই পর্যন্তই। আল্লাহ হাফেজ।